Alright, so in this video we are going to investigate special case ray diagrams. Special case is when the object are at some strategic locations. For example, when the object is at 2f, or when the object is at infinity, or when the object is at focus. So we'll be talking about the three locations of the object. So let's start with a case 1, which is finding the image when the object is at 2f. So I would request that you continue with your work along with me. So the first things first, draw a lens in your notebooks. If you're lagging behind me, you can pause the video, complete the video and come back and play the video again. So start with drawing the lens. You can take any focal length of your wish. Let us say that you're taking a focal length of say 4 centimeters. If it is too large, you can take a focal length of 3 centimeters or 2 centimeters, your wish. But make sure that everything fits in your page. So we are starting with a focal length of 4 centimeters. What does it mean? Let us call this center point as O. What does it mean? That the length of OF, which is your focal length, it is 4 centimeters. This is your 4 centimeters. Mark our F prime as well, 4 centimeters on the other side of the lens, because the other focus would also be at 4 centimeters. Complete your working. So what would be the distance of 2F? 2F would be at 8 centimeters. This will be your 8 centimeters. So mark all these points and get your base ready to start with the construction work. This is going to be 8 centimeters. Right? If you want, you need not put all these labels of 4 centimeters and 8 centimeters because it will make your working diagram look slightly cluttered. But if you want, you can write in tiny neat handwriting, so all these details. For time being, I am removing all these measurements so that you all can focus on what we are going to do here. Alright, so complete your working. First things, I would like you all to draw the lens, mark some focus, the 2 focus, and mark the 2F and 2F prime. You can start with a focal length of 4 centimeters or 3 centimeters, 2 centimeters, depending on how big your page is. It doesn't depend what focal length you are starting with. You'll automatically get the same answers ultimately. Right? So let us start with the working for finding the image when the object is at 2F. Let us draw an object at 2F. Say that this is our object. Let us start with the construction ray, which says that if a ray is passing through the center, it will pass straight through it without any bending. It will pass straight through. Let us put some arrows as well before the lens and after the lens. A ray which passes through the center will pass straight through it without bending. Let us draw construction ray number 2, which says a ray which moves parallel to the principal axis. After passing through the lens, it moves through the focus. So it has to move through the focus. So that's your image with the arrowhead at the point of intersection, because we were finding the image of the arrowhead. Now use your ruler. This is the task for you. Use the ruler to find the height of the image and the height of the object. You'll see that they'll be of the same length. If the object you started with was 2 centimeters, the image will also be 2 centimeters. Right? So let us write down some of the properties that we have identified. When the object is at 2F, what happens to the image? What happens to the image? Let us write it down. Image is also at 2f. If you see, object at 2f, image is also at 2f, and image is of the same size. Image is of the same size as the object. This is your J. This is your one finding. That's your second finding. Finding number 1 and 2. For investigation number 1, when the object is at 2f, the image is also at 2f, and the image length and the object length will be the same. Alright, this is the first case, and very important thing, make notes and understand all these points very well. Let us come to the second case now. I'm erasing all the things here so that we can work with the second case. Find the image when the object is at infinity or very far away. So when the object is very far away or at infinity, say that the object does not fit here in the screen because it is very far away. Say like a sun, which is very far away, or your clouds, something very far away, distant, very distant. What does far away mean? Far away means that the object distance from the lens. Object distance is very great as compared to the focal length. Say that if your focal length is 2 centimeters, the object is say 100 meters away from you. That's very far away. That's also very far away. For very far away, you do not have to be really at the sun's distance. No. Very far away means your distance from the image is very large. If you see, I have put so many greater than sign as compared to the focal length, right? In that case, what happens? The rays of light that are coming from the object, the ray of light which are coming from the object, they appear to be coming parallel. The ray of light which are coming from the object, they appear to be coming parallel, and they will all ultimately bend and converge on the focus. They'll ultimately bend and converge on the focus. The image will be formed at the focus like this. A parallel set of light, whenever they fall on the lens, they always converge on the focus. This is something that we have already learned. Same thing we are seeing here. What is the basic thing that we have learned about parallel set of lines? When they come parallel. When they come parallel to the principal axis. Same thing, another way around, I am telling you. Say that the object is very far away and the rays are coming parallel to the principal axis, something like this. What happens? You'll get a dot image in this case because they are parallel to the principal axis. All the ray of lights will pass through the focus. That's one of your construction rays. A ray of light which comes parallel to the principal axis, after passing the lens, it moves through the focus. So you'll get a very tiny image here. Same thing which I drew earlier. Earlier the parallel rays of light were coming slanting. Earlier the parallel rays of light were coming slanting like this. Then also the image was at the focus. If they come slanting, then also the image will be at the focus, but the image will not be a dot image, but you'll get a longer image. But if the ray of light are coming parallel to the principal axis, you'll get a dot image. Alright. So what do you infer from the second investigation? When the object is at infinity, very far away, then the image is at f. Simple. When the object is at infinity, image is at f. That's your second investigation. Let us move on to the third investigation. Let me erase everything, all the information before we understand the third information. Ref pen Find the image when the object is at F. So let us take an object at focus. Let us take an object. Let us see that the object is a dot object. It is a dot object sitting at the focus. This is your object, a point object. So any ray of light which comes from the object, because it is coming from the focus, it will pass parallel to the principal axis. Any ray of light, we know it is your construction ray, one of the construction rays, which says that a ray of light which comes through the focus, it passes parallel to the principal axis. These rays of light which you see, 1 and 2, because they are coming from the focus, they are emerging parallel. Now these rays of lights are parallel. Will they ever intersect? No, they will never intersect. So where is the image formed? The image is at infinity. Image is at infinity. So that's how you call the image when the object is at focus. When the object is at focus, you call it that the image is at infinity. So this was your investigation on special case ray diagrams for finding the images, when the object is at 2F, at infinity, or at F. If you pay close attention, point number 2 and 3 are exactly opposite of each other. Point 2 says when the object is at infinity, then the image is at focus. Your image is at focus. Right? And point 3 says when the object is at F, the image is at infinity. They are opposite of each other, so easy to learn. Alright, so this is the end of our investigation. We'll take up these concepts to understand the applications when we'll be talking about cameras, projectors, and magnifying lenses.